Thermocouple. So this is my thermocouple. It produces a change when there's a temperature change. The change in voltage or current or resistance. What does this thermocouple produce when you give it a temperature change? It's a voltage, it's not a resistance, huh? So you give out a voltage. And the voltage is sensed by this transmitter, right? So we're going to connect up a circuit. Okay? So instructions, read through yourself. The test instructions may be different from the experiment instructions. So let's go straight to the point to see during the test what would you need to do. You learn to connect up a circuit. Okay? And make sure that you have all the components. The transmitter is here, and you have a ammeter and a voltmeter, which is using the desk or the handheld type. Okay, and you have a DC power supply, and you have a resistor, adjustable resistor block, the duct resistor. Okay, so once you have everything ready, let's see how we can do the connection. Usually, students will have the problem is that they look at this thing and they say, okay, it looks kind of complicated, I don't know what is what, I can't connect. And then you raise the question, how to connect? So then, when I go over, right, I'll ask very basic questions. Transmitter come out, there's a plus. So, this is the transmitter, comes out. Which is the plus wire? Red. So the students will know that it's red. Then after that, I'll ask them, from the plus, right, where does it goes to? So they'll follow this, and then it goes to the resistor. So you know that there's a plus, and you know that the plus goes to a resistor, according to the circuit. Then you look at this resistor. Very naturally, right, you will have no choice, you have to put it in one of the holes. Then the next question is that, if you're asking, which hole should I plug into? Then we go back to the basics of a resistor. Any hole will do, because there's no polarity. So if you remember what we are taught as an electrical engineer, your basics, PEEE or DE, then when you come to do an experiment in year 3, you should not have problem with it. No need to doubt yourself, just recall what you have been taught. Okay? So it goes to the resistor, and then what I'll do every time I connect the circuit is that I will use a pen or pencil and then shade off the line that I draw. Once I do that, it means that that line is covered. If I do that for very complicated circuit, I will make sure that I don't leave out any wires, because every one that I have connected, I will have colored it, highlighted it. If you do that, then you will get everything correct. So after this resistor come out, we will go to a ammeter. So take a wire, comes out, goes to a ammeter. This is an ammeter, then please set it as an ammeter first. Okay? Ammeter, okay. Then ammeter. Milliamp. Comes out. Okay, so I'm done already, I shade this part. Then ammeter comes out, goes to power supply. 24 volt. Set my 24 volt first. 24 volt, 16, 23, 24. Then after that, set my current. What is this current? I set it as 0.24, means that is 0.24 is 240 milliamp. Later we will see. This is a limit that I set. Okay? And I plug it into the plus. Okay, I'm done already. Then the minus will goes back to the transmitter. So this guy goes to the transmitter. Okay. Too short. Okay, careful. Too short. Okay, I'm done. Okay? And I power on. The moment I press the output switch, it drops to 0.01. Very natural, because you set 240 milliamp doesn't mean your load will draw 240 milliamp. The load draw whatever current it needs. In this case, it's only 10 milliamp. Enough already, sensor only. Okay? So you can set 100 milliamp is good enough. Okay? The reason we don't want to set 3-4 amps, we want to protect. In case our circuit have any problem, the current limit help us protect our equipment. Okay? So once that is done, then we can see this side is settled. Then on the left side of the transmitter, there's 2 wires coming out, and that is your voltmeter. Okay, supposed to be connected to the voltmeter. So set this as the voltmeter. Volt. Okay, this is auto range. Millivolt or volt doesn't matter. But in some cases of handheld voltmeter, you may need to set your range. Okay, so I set it to my voltmeter. So I have this 8 milliamp. Okay, and my volt is 0.1 millivolt, very small. You can see that here there is 2 numbers fluctuating. One is 8 milliamp, the other is 25. You can't see later you can see 25 degrees Celsius and 8 milliamp. So the 8 milliamp is the same as this. So actually I don't connect this, but the experiment calls for it. We connect accordingly. There may be some transmitter that don't give you the milliamp. Okay, so in this case the milliamp we can measure ourselves if it doesn't give us. So it's 25 degrees. Just now I heated the water, slightly hot, slightly warm. Let me put it in and we see what happens. Okay, so 25, we see, is there any increase? 26.9. I can start boiling the water. 28.9, and we see that the milliamp keep increasing also. So what you're going to do is you're going to tally this, tabulate this table. Okay, at 30 degrees, 40 degrees, all the way to 80 degrees. Every 10 degrees, you will take down a reading and plot a graph. Okay, so it's going to jump pretty fast. Now I'm at 40 degrees already. Okay, and you see that it's 10 milliamp, and millivolt 0.95 millivolt, rather very small. Okay, so any questions regarding the connections? So once your connection is no problem, your reading should have no problem. Then the rest is just answering the questions. Okay, you try to answer your questions on your own, then I'll provide a solution after that. Can? Okay.